I had a problem this holiday season, which was being exceptionally bored and lonely. So, being the problem solver that I am, I coded an entire script to make TicTacToe in Python single player, which is very useful because that means I don't need anybody else to entertain myself, which is great. So basically how this script works is it prints out, it has no graphics, but it prints out a TicTacToe board, as you'll see in a second, where if I press run, it'll print out a TicTacToe board. So I've made this with a bot as well that will play the best move for blocking off the player or completing its own row, column, or diagonal, as you'll see in a second. So I'm just going to do 5. This TicTacToe board works so that essentially 1 through 9 corresponds to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that makes it so that a user can input a number simply and then have that be put onto the board. So if I choose 5, that'll be the middle. And the computer, if there's no apparent blocking or completing that can be done, it'll choose a random square. And in this case, it chose the bottom left corner. So now I'm going to demonstrate it being able to block the player. So now if I do, let's say I do 6. It knows to block me. It knows to block this row. So now comes a dilemma where, what if I say pick the top right corner? What if I do 3? Will the bot block me, or will it take the obvious win that it can get over here? And the answer is it'll take the win. If I do 3, it'll take the win and it displays an appropriate message. Wow, you suck, the computer wins. So I'm going to do play again because I'm not going to end on a negative note. Now I'm going to demonstrate how the computer can also, or actually how, basically if I do 1, computer does something. If I do 1 again, it's not going to let me, it says move not valid, please choose another option. If I do 5, same thing. So I'm going to do, I guess, 2, let's say you do 2. Okay, it blocked me there. So I'm just going to try getting a tie, as most TicTacToe games should end if done properly. 7. Block that. Alright, nice. Now I should say, game over, nobody wins. So that is basically how this whole thing works. Now I'm just going to explain the code itself, which is admittedly more boring than the actual game. So how this works, it's kind of convoluted. So basically, in a nutshell, this whole game, it starts off with 2 lists, a bunch of underscores and a bunch of zeros. Now these underscores, you've actually already seen them. They're right over here. So see how all these underscores, they correspond to each of these, and they're printed up above, but right down here, they are put down below. And as the game progresses, each of these underscores is replaced with either an X or an O, until eventually there's no more space. Now accordingly, there is also a bunch of zeros, and each of these zeros corresponds to each of these slots. Now, you might be asking, why would I need to do zeros when I already have this list? Well, I could have maybe had some other way to figure this out. This was just the first that came to mind. What I did was I had a bunch of zeros, and then as the game progressed, whenever a player made a move, that 0 was turned into either a 7 for O, or it was turned into a 1 for X. Now you might be wondering, why 1s and 7s? Couldn't you just do 1 and 0 or 1 and 2? I needed numbers far enough apart so that the computer could distinguish between 2 X's or 2 O's instead of 1 X and 1 O. So let me try to explain this. So basically, let's say I start off the game by filling in a 1. Now you see that this O over here, this means that the first item in the list over here, it was turned into 7. And then this was turned into 1. So now if I were to put a little O over here, I would have 7 and 7. So what the computer does to figure out if there's been a win is it has a bunch of these combinations here. And it takes these combinations and looks at 3 numbers, and it corresponds those to the squares. And then it adds all of them together. And if they add together to be either 21, which is 3 sevens in a row, or 3, which is 3 ones in a row, then it'll say game over. And this might seem a bit convoluted, but if you go back to the bot, the same concept is used, which is really useful because I can apply it to both 2-player and also single player. Because the bot essentially says, oh, are there 2 sevens in a row? That would equal 14. And then it knows to block me. And then also, if I go down here, it says, are there 2 ones in a row? That means it should add up to 2, and then it knows to block me. And then it goes, which one of these is still open for me to take, and then it takes it. And then it either blocks or completes the row, column, or diagonal. So that's basically all of the code. The rest of this is just a bunch of formatting like this, or just inputs, things like that, move not valid, stuff like that. It's just formatting. This was originally 2-player. I might have mentioned it earlier. This was originally 2-player, but then I made it so that a bot could be attached, and then it could play the other side every other turn. So now I'm just going to try to win, because I don't want to end on a negative note. Let's do 5. Oh, it knows to block me there. Shoot. I should have made it easy mode for this so it doesn't end in a tie every single time. Okay, clearly I don't know how to play this game. Nobody wins, yay. I might be here for a while. Another thing I did was I implemented a pause. Normally this would be instantaneous, but I made it so that there's a 1-second pause to kind of make it less confusing, make it look like it's loading. It could be instant, but it just looks better this way, in my opinion. I'm going to do 3. Okay, this is... Nobody... Okay, hopefully this is the one. Please be the one. You gotta be kidding me. Oh! Great, I accidentally double trapped it. So now, if I do 9... Oh, okay, wait. Here, this might be one problem that I forgot to sort out. If I do this, it might actually say game over, nobody wins. Let's see. Oh, okay. Player O wins. That's great. So I sorted that out earlier. So I'm just going to say no, I would not like to play again. And that is the project.